Hello there, it's Alana, and I'm going to see if I can navigate you through the slightly tricky problem of 4.1, number 33. Again, that's what it is in the study plan. What it is in your actual assignment, who knows? But it says researchers wondered whether the size of a person's brain was related to the individual's mental capacity. They selected a sample of 5 females and 5 males and measured their MRI counts and IQ scores. The data is reported to the right. So complete parts A through D. Now I'm going to do an example. So let me click on that. But of course it's going to work very similarly to your problem. So you can see here, you got the 5 female MRIs, the 5 female IQ, the male MRI, the male IQ. If you're interested, over here is the critical values table, which is also available in the textbook, also available in your table card, which comes with every book, and it's available online in the exams and reviews piece if you're an online student. Okay, so over here, if I click on this, I'm going to copy the table to the clipboard as I usually do. I never open in StatCrunch because I prefer usually to copy to the clipboard, and then I pasted it in here, and you can see that. And then what I'm going to do is, because the first problem wants them all together, so what I did was I copied and pasted and made a new column, which is just MRI. So there are the 5 females, there are the 5 males. Here are the 5 female IQs, here are the 5 male IQs, right? So I just put them all together. All right, so the first problem wants to look at a scattergram of both of those. Okay, so now that I have them all together, I just highlight that data, go to Insert, Scattergram. Boom, there it is. Now, of course, this doesn't really have a good x-axis scale for us. Our lowest MRI size is in the 800,000s, I think. So I'm going to click down here on these numbers, right-click Format Axis, and I'm going to change my minimum to a fixed number of like 800,000. Enter. And I'm going to delete this because I don't really need to see the IQ thing. I'm going to go up here and do the usual MRI versus IQ for males and females over here. And then I'm also going to insert, let's see, if I click on layout, there they are, axis titles. So I need a horizontal axis, which is MRI count, I think it was. And then I'm going to click again, vertical. I usually like the rotated, and this was IQ score. Cool. There we go. Now another nice thing to do a lot of the time, and it's going to be nice here, is to right click on one of those dots and you add a trend line right there. And it's going to say linear, and down here at the bottom you can display R squared. You can actually display the equation right there. And that's kind of handy. So you don't have to do it, but it's kind of nice. All right, so we've displayed R squared. Wonderful. Let's go back. So we've made a scatter plot. I kind of threw in the line. You don't really need the line, but I threw it in there because I know what's coming. So you choose which of the 4 pictures actually matches the one that we graphed. And you can fiddle around. You can see that they made this graph at 780. And let me close this for a sec. If you look at the ones on the pictures, you can kind of figure out, oh, okay, 780 looks like it's one of these two, that kind of thing. And then you choose from there. You can fiddle around with the axis down here, format axis. You can make it so it's 780,000 if you like. Something like that. And then you can make it so the tick marks are what you want. I mean, you can fiddle around to make it match what they have, but honestly, you usually can figure out which one it is just by kind of looking at it. Okay, then they want to know the correlation coefficient. Now, there are a few ways to get this. Oops, let me go back to the example. There we go. All right, so we choose the scattergram, and then they want the correlation coefficient. You can ignore all this by hand work and all that jazz. We don't need any of that stuff. But we do want to know what it is and be able to compare it to the correlation coefficient table. So now you can get the correlation coefficient a lot of ways. I mean, the first thing you should notice is that if you get R squared, the correlation coefficient is R. And no, that's not by accident, right? So it's equal to the square root of R squared, which would be 0.5098. That's the kind of thing I can give to you on an exam, right? Because if I give you R squared, I can totally ask you what R is, and you don't really need Excel to be able to do that. That was just a simple calculator thing. Or if I gave you R, I could ask you for R squared by the same token, right? So another way to find it is if you're using Excel, you can use Corel. that's a feature, right? A function that you can use. So equals choral. You say array number 1, those are your X's. You highlight all the MRI scores, comma, array number 2 is the IQ scores. Close your parentheses, and there you go. Now you can see they're a little bit different, and that's because the 0.5098 is rounded. So the bottom one's actually a little bit more accurate than the top one, but they'll both work because they both say 0.714. Now notice there's 10 scores here, right? So if you look at your correlation coefficient table right here, you go to where it's 10 and you see 0.632. So as long as the absolute value of what we found is larger than 0.632, we're golden. And this is, right? 0.714 is larger than 0.632. So the data appear to be linear. Not 100% sure, but we think so. All right, and of course we find out more carefully with residual plots from section 4.3, but you'll hear more about that later. Okay, so real quick, I just want to run over to StatCrunch and show you how to do the same thing. So what I did, I copied and pasted, made a new column just like before. Go to Stat, Regression, Simple Linear. You tell it the X variable is MRI, the Y variable is IQ, next, 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 next. We really don't need most of this stuff. You go to calculate. You can see right there the correlation coefficient is 0.714. Oops, let's go back to the edit. I forgot to make it do a graph, which is right here, plot the fitted line. So if I click that, then when I do it, see it'll have next down here, and you have a scatter plot right there. There's not much you can do to make the dots bigger, which is unfortunate, but other than that, it's doing everything you need it to do. Very, very quick, very simple. And it also gave you a whole bunch of other stuff, which we'll learn about later. Oh, by the way, did you see R squared right here? 0.5098, just like that. And there's R, which is 0.714. All right, next, they want us to do a scatter diagram, but use different plotting symbols for each gender. Ugh. All right, that's going to be kind of a pain. Excel is the better one to do this with, honestly, because in case you haven't noticed, StatCrunch is not great about graphing. But let me see what I can do here. So I think, if I remember correctly, let me double check. Hold on one sec. Okay, here's what you do. You're going to highlight, and please understand, this is not the only way to do this. This is kind of the quickest way I could think of to do it. So I'm going to highlight my females right here, just the females. Insert scatter plot. Click on that. I'm going to kind of move this down because I kind of need the rest of this data available, but there it is. All right, now you can see you only have the females there, which is kind of sucky. That's okay. So we'll deal with that in a minute. So I'm going to select data, and you can see I've got the female IQ scores right there. I'm going to click another one. So see this, where I'm going to click add. I'm going to add another series. This is going to be the male series. I'm going to click the male IQ right there. And then series X values. So the X values are the MRIs for those males. So I'm going to add that. And then down here I'm going to say equals those male IQs. Those are the Y variables. So I got my MRIs for the men and my IQ for the men, and I'm calling it that series name. Okay. And then I'll say okay. And there you go. You got your females and you got your males, and they've got different number or different symbols, different whatever. Couple things. Again, I'm going to adjust this axis because this is terrible. So I'm going to right click, format the axis. I'm going to start it at 800,000, just like before. If you don't like the whole female IQ thing, male IQ thing, you can just go up to where those cells are and type female. And then the male IQ was the other one, right? So let me go male right there. And then it's kind of obvious which one's which. You can fiddle around with, other ones. Okay. So then, I mean, if you want, you can fiddle around with, symbols. If I right click on these, let's see, format the data series, I can make it so that the marker option is that, and the marker fill color solid fill, but I don't want blue for the ladies. I want to click over here and make it hot pink or something like that. You can do that. And then over here for the guys, I'm going to right click on them, format the data series. See what I mean? You can kind of fiddle around with, and you can fiddle around with the borders. The ladies still have a blue border on theirs, which you might not want or whatever. Anyway, and they still have a red border on theirs. So you can fiddle around with the markers and stuff. And you can click over here, design, layout, and you can add axes title just like before, right? So this was IQ, score. And then the other axis was, let's see, MRI count. Cool. And again, you can add a title if you so desire. Let me throw that in there. MRI versus IQ for males versus females. Okay. All right, let's see what else they wanted. So we did the scatter plot, and then you'd have to choose that scatter plot, right? So you'd have to kind of look at what you made and kind of adjust it and pick the correct one from whatever sample they give you. Then they want to compute the linear correlation coefficient for the MRI count and IQ for males, or excuse me, for females. And if they'd want it for males, you can do that too, but let me see here. All right, so let me move this down here. And you can do this a couple ways. You can just kind of add a trend line just for the men or just for the females. See, display the equation. There it is, just for the females. Or you could do it again just for the males, like there it is. So there's the one for the females. Then I can right click on the men's blue dots, add a trend line, display the R squared. Right, there it is. So I can get that way. That's one thing I could do. Or I could go up here, and of course then I'd still have to take the square root of those because they're not good on their own. Or I could do equals correl for this array, comma this array. That's the female R. Female R. Oops, not female 3. That was silly. Female R. And then do it again for the males. Male R. And actually I think this already worked. Yeah, that's already correct because I copied and pasted. So there you go. That's another way to do it. Let's see if what my values are match. So 0.334, that's what I got. And then for the males, 0.284, that's what I got. Right? So pretty terrible. But let's see if it's terrible enough. So these were both 5, values of 5. So we would have to have a value of 0.878. Which we do not have. We are really low. So that means both of these are pretty terrible, and they're both going to be a no, right? And so what you're seeing is that by mushing the men and women together, it made it seem like there was a relationship, but actually it wasn't there. What you were catching was actually the gender difference, right? Men are larger, they have larger heads, so they're going to have a bigger MRI count or whatever. You know, there are other things going on here. Okay, so when they're all together, it seems like there's a strong positive relationship, but actually, individually, the male and female showed that there weren't strong relationships. So same data, mushed together, seemed like there was something, but once you separated it, no good. Now, real quick, you can't really do the two-colored thing in StatCrunch. Hold on one sec. So you have choices. You can either do them separately or you can do them all at once. Here, if I make a gender variable here and I say this was F, 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 M, M, oopsie, M, 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 M. So you can do it separately. You can, like, you know, just do regression with, you know, the X variable is the female MRI, the Y variable is the female IQ, and so on. You can just do it twice. Or you can do what I just did. MRI is the X variable, IQ is the Y variable, and my group is my gender variable, that FFFMMM thing. And next, ignore this page. You don't care about that. We don't really care about that. Plot the fitted lines, right? Beautiful. And then say next, calculate. And what will happen is it'll give you, this is for gender female. Gender equals F up here. And there's that correlation coefficient, 0.333. Next, there's the graph for just females. Next, there's the men stuff. Gender equals M, male. And then you can see 0.284 is the correlation coefficient right there. Next, there's just the males. Cool? So it won't really do the double graph thing, but it will let you find the correlation coefficients for each one of them separately, and a whole bunch more in there. Right? There's a whole bunch of stuff in here. All right, I hope that helps. We're done with that problem. See ya.